Hello everyone. This is the start of a new series where I simplify electrical engineering concepts. And today we're going to start studying one of the most fundamental laws in electrical engineering. This is known as Ohm's Law. So, what is Ohm's Law? Ohm's Law, it is it is the relationship between voltage, current, and resistance. Simply, it is the relationship between voltage, current, and resistance of the conductor, right? Ohm's law is Ohm's law is a basic principle that explains how the voltage, current, and resistance are related in an electrical circuit. Okay, so Ohm's law is expressed using this very simple equation: V is equal to I times R, where V is voltage, I is current, and R is resistance. The voltage is measured in volts, current is measured in amps, resistance in ohms, right? So what does this mean? What does in simple words this mean? This means that the voltage across a resistor is equal to the current flowing through it. So graphically, let's assume a conductor. Conductor would have some sort of resistance, right? So the voltage across a resistor is equal to the current flowing through the conductor multiplied by its resistance R. Simply V equals IR, right? So this equation V equals IR can be represented in three forms, right? So if this is form number one, where V is the subject, a second form would be where we make I the subject, would be V over R. In the third form, where we make R the subject, it will be V over I, right? So now we are gonna analyze this equation a bit. So let's pick this and let's make two assumptions. So for the first scenario, the first assumption is going to be that our resistance R is constant resistance. So if the resistance is constant, the voltage across the conductor is directly proportional to the current flowing through it. So if the voltage were to be increased, this would increase the current as well, right? That's the first point. Now let's move on. Now uh, let's make V constant. If V is made constant, let's see how this affects the relationship between current and resistance. When the voltage is constant, you could see that the current and resistance, they are inversely proportional, right? So what that means is when we increase the resistance, the current decreases, right? So let's do a small example. Uh, Let's say, okay, so imagine that you have a resistor, right? Imagine that you have a resistor with resistance, let's say 10 ohms. You have a resistance which has resistance of 10 ohms, and you supply or you pass a current of 2 amperes. So current of 2 amperes flows through the resistance. So what would be the voltage across it? So by Ohm's law, voltage is equal to current times resistance. The voltage would be equal to I, which is 2 amperes, times the resistance, which is 10 ohms. So how much do we get? We get 20 volts, right? Uh, yeah. Now let's talk about the applications of Ohm's law. So in electronics, Ohm's law is used everywhere, right? It's mostly used when you're designing circuits. Designing circuits, uh, when you're selecting resistor values, calculating power consumption, and even debugging. Even you're debugging problems in electronics, there's Ohm's law involved. In fact, it is one of the first tools that you'll use in almost every electrical or electronic project, right? Uh, yeah, that sums up everything for Ohm's law in this video.